Okay, so now we saw a little bit about heat transfer, and what I want to show you right now is just a couple of little, I guess, demos or whatnot. Hopefully you can see. But basically we can have two types of changes in energy. We can have something when it's released, and when energy is released in our reaction, or when energy is absorbed. Okay, these two different types of reactions. Every reaction will have either a release of energy or an absorption of energy. Now, depending on what the reaction is, that might be a very, very vigorous or violent energy release or absorption, or it might be very, very mild. What I mean by that is you can have a huge change in temperature one way or the other. Energy that is released is when it gets hotter, okay? The surroundings get hotter, is called an exothermic reaction, okay? So think of it this way. If I'm holding a beaker, and I'm going to do a demo, but if I'm holding a beaker, okay, and I put something in there and there's a reaction that takes place. If the reaction that's taking place releases heat, then as I'm holding it, my hands are going to feel a lot warmer. Why? Because that heat, that energy is being released to the surroundings. My hand being the surroundings is going to feel warmer. If I have an absorption of heat, it's going to feel colder, and that is called an endothermic reaction. So exo, just like an exoskeleton that's on the outside, on the outside like an exoskeleton. Exothermic, to the outside, it feels warmer. And endo is an absorption. So again, if I use my beaker here and I put some substance in there and it absorbs heat from that, then my hand's going to feel colder because it's even absorbing some of the heat, some of the energy from my hands. I've got a couple of examples. The first I want to show you is an endothermic reaction where heat is absorbed, okay? And if you can think of those cold packs, so again, it's going to be something that feels colder, those cold packs, really what we have is a little baggie of, those cold packs that you use for like first aid. If you hurt yourself, you kind of bust that interior bag and then you shake it up. Well, what you have in the exterior bag, oftentimes, and it depends what the substance is, oftentimes you have ammonium nitrate. And ammonium nitrate, when it reacts with water, when it gets together with water, is going to form a very cold temperature. It's going to get a drop in temperature. So that's absorbing some energy. So those cold packs, you just bust that interior bag, shake it all up. The water combines with the ammonium nitrate, and you get colder temperature. So I've got a little stirring. Hope you can see this. I've got a little stirring plate here, and I'm going to grab some water. So this is just water, and just going to turn this. I'm just going to turn it on, and I have a thermometer. If I can see it here. And I'm going to take the temperature of this water. It's about room temperature. It's been sitting out for a little while. It's reading about 21 degrees Celsius. Let's see if you can see the temperature. About 21 degrees. Okay. I'm going to now place some ammonium nitrate in the beaker. It's going to stir, and we should start, you can see it's starting to dissolve, we should see a temperature drop. I'm reading 17, 16, even more, 15-ish now. Again, I don't know if you'll be able to see. Hopefully you can. My temperature is down now to 13 degrees Celsius. So again, we got a decrease in temperature, and again, that decrease in temperature is because for that reaction to go forward, it needed to absorb some energy, so temperature went down. So please realize that the value for that energy change is positive. And you can kind of see that here. Positive, even though it went colder. I have a demo. Hopefully we can show it here. Oops, it's going to dance unless I turn my... Show you an exothermic reaction. Exothermic reaction. Now I've got my water in my beaker. And again, this was room temperature water. It's reading about 20 right now. Again, if you can see, let's see, yeah, about 21 degrees or so. And this time I'm going to put sodium hydroxide. Sodium hydroxide. Let me go ahead and just kind of, whoops. So now I'm going to take some water and take some sodium hydroxide and put that in there. Now sodium hydroxide should make it an exothermic reaction, which means it's going to release heat to the surroundings, which means it should get hotter. Again, notice that the energy Q value would be negative. All right, and that's important to recognize. Positive for endothermic, negative for exothermic. So here's some sodium hydroxide pellets. And I'm reading 21 degrees or so. Get that all in there. They get a little sticky. Looks like they melt. Oops, I want to get them all in because I'm making a specific concentration of something. And now, see what my temperature is reading now. It's reading around 24, slowly going up. 25, 26 degrees, continuing to move up. Again, let's see if you can see it a little bit here. I know it's small down in the corner, but it's reading now at around 20, almost 27 degrees. So an increase in temperature. I'm going to let that kind of keep going. I want to show you one more exothermic reaction again. Turn off the lights real quickly. And what I'm going to do here is get a little methanol. So a little bit of methanol. And I want to, I'll put my goggles on. I should have had them on earlier, but a little bit of methanol, and I'm going to light it up. You should be able, maybe you'll see the flame. It's difficult to see. But obviously just this right here is also, I mean, I can tell you this is pretty darn warm. It doesn't take long for the methanol to burn out. It evaporates very quickly. But again, a release of heat and therefore an exothermic reaction. Okay. So that's heat transfer, exo and endothermic reactions.